Here's a quick briefing to help prepare you for the first lab. You're going to start out with a breadboard. Hopefully you've already watched the video on breadboards and the one on power supplies and the one on multimeters, because you're going to be using all three of those devices today. I've connected this breadboard over here on the left. I've connected it to the power supply that can go up to 20 volts. I'm also going to be using some wires. Now you have two choices. You can either have a simple hookup wire like this, or you can have sort of fancier connector wire like this. The fancier connector wire is a little bit easier to use, so I'm going to go ahead and use that. But if you happen to have just regular hookup wire, that's no problem, so don't worry about that. We're also going to be using a couple of little light bulbs. So we have one light bulb that I've color-coded with an orange stripe, and one light bulb that I've color-coded with a blue stripe. So these are two different electrical elements. They have different electrical characteristics. In this video, I'll just focus on the one that has the orange stripe. Now what we need to do is we need to apply a voltage to the two terminals of this orange light bulb. And so I'm going to plug it into the breadboard. Now you might be tempted to plug it into two of the lines that are vertical here. But remember, those lines are connected to each other. So we can't do that. Instead, we need to connect them to two lines that are not vertical. So I'm going to connect them to two horizontal lines side by side here. So you can see here, as I plug this in, it's going into two separate vertical wires. Now I'm going to connect the top, I'm going to connect the 5 volts. You'll notice that, I'm sorry, not 5 volts, the power supply is going to be connected to the top row here. So I'm going to go ahead and plug that in here, and then I'm going to plug this into one side of the light bulb, and it doesn't matter which side. Light bulbs are symmetric, so I don't need to worry about which side. And then I'm going to plug the other side into the, so here I'm plugging it into the other side of the light bulb, and then this is going down into the blue stripe on the bottom. So between all the various connections that we've made, I have the power supply over here, and then the power supply is delivering voltage through the red and black cables. Those are going into the red striped wire, or the red striped bus, and the blue striped bus. Then it's going through the blue wire, through the light bulb, and then into the yellow wire, and then down to the blue striped bus. And then I know it's off camera here, but I'm going to begin to increase the voltage, and you should be able to see the light bulb starting to brighten up. So right here I'm at about 5 volts. And so as I continue to increase the voltage here, remember that the rated voltage is 14 volts. Here we're at about 8 volts, 9, 10, 11, 12, 13, 14 volts. So I'm going to try to get this right about 14 volts. There's 13.98 volts. And it's nice and bright. You can see the light bulb is burning very well. And if I've correctly hooked this up, then we would expect that the light bulb is going to be drawing the amount of current that it is rated for, which is 80 milliamps, 0.08 amps. And if you look at the voltage supply here, you can see that it is right at 0.08 amps. I don't always trust the built-in ammeter on the power supply though, so I'm going to use the digital multimeter to verify that with better precision. So here I'm going to put the digital multimeter beside this so that we can see it at the same time. And now I have to actually break this circuit. I have to, and by break I don't mean destroy, I mean I simply have to connect it such that I put the multimeter in series with the rest of the circuit. So when I connect it in series, that means that I'm going to need to break one of the connections. So I'm going to take this wire out. So I'm going to take the yellow wire out. That definitely turns the light bulb off. I'm going to have a different wire that's going to go to ground. So that wire goes to ground. You can see if I touch these two wires, then I'll reconnect the circuit and the light bulb will light. But what I need to do now is find out how much current flows through these two wires. Now the way to do that is with the ammeter. And you'll notice here that I've plugged this into the multimeter slot, and I have this one over here on the 2000 milliamp reading. And I've got the two plugs right here. Well, I could just touch those, but I want to make a better permanent connection. And so I'm going to use what's called an alligator clip. So here is my alligator clip, and it's called that, of course, because it looks like the mouth of an alligator. So I'm going to connect one of these to this terminal, and I have a black one that I'm going to connect to this terminal. This is going to make a permanent connection to this multimeter. Now I'm going to connect over here the terminal of the multimeter, black to black, and red to red. And I've now completed the circuit again. The light bulb is lit. And if I come up here, you can see, what did I say it should have been? It should have been about 80 milliamps. we're getting at about 78.8 milliamps. I'm not quite at exactly 14 volts. Let me crank this up to just right at 14 volts. And when I do that, I get 78.9, 78.8. I'll hit the hold button so it'll stay on a constant number here. That's really close to the 80 milliamps that we would have expected. We're not going to get exactly 80 milliamps because, of course, there's some variability in the resistance of the light bulb.